So the word we're looking at here is transversal. Now, when I think trans, I think transportation or transition. It's where kind of two things meet, right? Transportation means you're going from A to point B, so it's that transitional phase. Transition means, whether you're, transitioning into college or transitioning into moving to another area. And so think about that word trans. It connects two things, okay? And what we're talking about today is when a line connects two other lines, what kind of angles do they form? And it is kind of a lot of information, but there will be no measuring angles today, okay? It's more or less just getting concepts stuck up here so that when we do start to measure angles and stuff, we can know these terms really well. So here's kind of the first page, and all I'm doing here is showing what a transversal is. And so line T here, the blue line, is the transversal to lines L and M. Okay, for the simple fact that it's a line that crosses through two other lines. Okay. Now L and M don't have to be parallel. You can see they're not parallel for the fact that T, which is transversal, crosses through both of them. Okay, and also you can think about the fact L and M don't have to be going up this way. They could be going side to side and have a line going through them. So it's just simple. It's a line that goes through two lines. So T is a transversal, L and M are your two other lines. Next, we're going to talk about interior angles, okay? The interior angles are angles on the insides of the two lines that aren't your transversal. Okay, so in other words, F and G are both on the inside of L and M, right? E and H are angles. So again, we're talking about angles here. They are both on the inside of the lines. So angle F, angle E, which is right here, angle H, which is right here, angle G, all are on the inside of the two lines. They kind of face each other. Okay? That's why we call them interior angles. The next term is opposite, exterior angles. They are on the outside of the lines. So C and D are to the right of M, A and B are to the left. So they're on opposite sides of where the interior angles were. So exterior angles are on the outside of the two lines, in this case L and M. Okay, so just as a refresher, these are the interior angles, they're on the inside. These are the exterior angles, they're on the outside. And we're going to be using the same angle names for the next few examples. Okay, so here's kind of a more involved expression or angle concept, consecutive interior. So the best definition that works for me at least is that they face each other, and since they're interior, we know they're on the inside. So consecutive means that they face each other. Notice that F and G are right across from each other. So F and G are consecutive angles, okay? E and H face each other on the inside, so they are also consecutive interior angles. Okay, you couldn't say that E and G are consecutive because they're on opposite sides of T. There's another name for that which we'll learn, okay? So E and G are not consecutive. They're on opposite sides of line T. Neither could you say that F and H are consecutive. They're also on opposite sides of this transversal. They're only consecutive interior angles when they're on the inside and they face each other on the same side of T. So F and G are both above T and they're on the inside, so that makes them consecutive interior. E and H are below T. They're both on the inside, so they're also consecutive interior angles. Interior. Why does consecutive exterior not exist? Right. So in other words, if there was an angle here, which I think we called B, and D here, they're both on the same side of T, but they don't face each other, so they're not consecutive. They're just exterior, right? So consecutive exterior doesn't actually exist. The next term does, which is kind of what we were just talking about. So when they're both on the inside, but they're on opposite sides of the line, we say that they are alternate interior angles. They're on opposite sides of the transversal. So for example, F and H are both on the inside of these two lines, but They're on opposite sides of the transversal T, so we call them alternate interior angles. The word alternate means change sides, right? So they're on different sides, but they're still interior, so they're alternate interior angles. Same for E and G. E is below T, and it's on the inside. G is above T, and it's on the inside. So since one's above and one's below, and they're both on the inside, G and E would also be alternate interior angles. Alternate exterior angles, same concept, except they're on the outside. So notice how A and D, they're both on the outside of L and M, so they're exterior, and they're alternate exterior because D is below T, A is above T, okay? And then B and C are also alternate exterior. B is below T, and it's outside of L. C is above T, and it's outside of M. So B and C would also be alternate exterior angles. And again, A and D would be the other pair of alternate exterior angles. They are angles that are also on opposite sides of the transversal and exterior, meaning they're on the outside. The other term is corresponding angles, okay? So the reason A and G are corresponding angles because they're both above T and they're both to the left of each line. So G is to the left of M, A is to the left of L, and they're both above. So we call them corresponding, okay? Kind of like same position. In other words, A you could think of as northwest of this corner, right? And G would also be northwest of this corner, okay? And so similarly, E and D, if you look at E, E is southeast of this corner, and so is D. And that's why we use the word corresponding, because they have similar positions. And of course, there could be other examples. We could say this angle and this angle are corresponding because they're both southwest of these intersecting lines. In other words, this one's south of T and this one's south of T. This one's west of or left of L and this one's left of M. So corresponding means in similar positions. So let's answer some questions together. So we have a new diagram here. Go ahead and jot this diagram down. Can somebody tell me which one of these is the transversal? Yep, this line right here. Okay, this is our transversal. The other two are the other two lines, right? And they don't necessarily have to be parallel. Although when they are parallel, there's a lot we can say about the angles and how they're related to each other. So it won't take you long to just make this quick sketch on your paper, and then we can do some examples together. All right, first question. Name an exterior angle. Yeah, somebody give me an example of exterior. What would be an exterior angle? So, yes, 3 and 6 are both on the outside of these two lines, and 1 and 8 would also work. We're just going to write one example. We're going to say 3. Okay, how about an interior angle? So an angle on the inside. 4, 5, 7, and 2 are all on the inside of these two lines. That's correct. I'm just going to write 2 for simplicity's sake. Okay, and if you don't get this copy today, that's fine. I'll give you time tomorrow to get it done. I just want to finish this before the bell rings. Name 2 adjacent. Adjacent means what? Next to exterior angles. So 2 angles on the outside that are next to each other. 1 and 3 are both exterior next to each other, or you could say 6 and 8. I'm just going to say 1 and 3. Name 2 alternate exterior angles. We're going to do 8 and 1, okay? Because they are on the outside, but they do not correspond. They're opposite each other. So 8 and 1 would be alternate exterior, or you could say 3 and 6. Two consecutive interior angles. Consecutive interior. Remember, consecutive means What? Facing each other. So 4 and 7 or 2 and 5. Good. It's different than corresponding, right? Two alternate interior angles. Who wants to share that one? Alternate interior. Anybody? Yeah? 4 and 5 or what? 2 and 7. They alternate. They're not on this. They don't face each other, but they're still on the inside. There's just one more question. The last one is two. We won't do vertical because we've already done that. Name two corresponding angles. So two angles that are in the same position. Anybody? How about 3 and 7? They're both northeast of these intersecting points. You could also say 1 and 5, 2 and 6, they're 4 and 8.